Welcome back to Course 2 in Saxon Math. We're talking today about Lesson 6, Factors and Divisibility. Here are our objectives for today. After this lesson, you should be able to identify the factors of a number, identify common factors and the greatest common factor of two numbers, and test the divisibility of numbers by 2, 3, 4, 5, 6, 8, 9, and 10 using their different divisibility rules. Review from the last lesson. We talked about place value. Remember the commas. The commas are where you say the different place values like thousand and million and billion. Those are important. Anything over 4 digits needs a comma. And expanded notation, taking expanded form a little bit farther by making those little multiplication problems with the place values. Now it's time for our new concept, talking about factors. So before this lesson, factors we talked about with multiplication. The numbers you multiply together are the factors, and the answer is the product. So when we're talking about the factors of a number, those are all the numbers that can be used to create multiplication problems that equal the number we're talking about. So for example, if we were finding the factors of 24, all we have to think about is what multiplication problems do we know that equal 24? So here I listed them. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And we're not going to repeat by flipping with the commutative property. So 1 times 24 is the same thing as 24 times 1. That's why you only see 4 multiplication problems up there instead of 8. Now we just list those numbers from least to greatest. And there they are. So those are the factors of 24. You can also think of them as the numbers that you can divide 24 by without having a remainder in your answer. Common factors. Many different numbers share factors. They might have some of the same factors. Those are called common factors. So if we wanted to list the common factors of 12 and 15, our first step would be to find the factors of each number. So here I use that same method that I just showed you by listing multiplication problems. Factors of 12 are 1, 2, 3, 4, 6, 12. And the factors of 15 are 1, 3, 5, and 15. So our common factors are any that overlap on the two lists. And in this case, the only two common factors of 12 and 15 are 1 and 3. Those are the only numbers that are on both lists. You can pick out the greatest common factor, the GCF, which is going to be important when we start working a little more with fractions, by just picking out the biggest number on that list of common factors. So the GCF of 12 and 15 is 3, because we only had 1 and 3 is bigger than 1. Now we're going to talk about divisibility, and this can get a little confusing, so make sure if you need to repeat this section of the video that you do that. These are important for saving you time later on, and it can take a little while to get used to using them. So divisibility is the ability of one number to be divided by another without leaving a remainder. So here's an example. 25 is divisible by 5, because if you do 25 divided by 5, there's no remainder. The answer is just 5. 25 is not divisible by 2, because if you divide 25 by 2, you end up with 12 remainder 1. So that can't be divisible. And we're going to go through the rules that we can use for some of these numbers to figure out divisibility without actually doing the division. It'll save you some time doing long division. started with that. Here they are, the divisibility rules. So, we'll start with 2. A number is divisible by 2 if the last digit is even. Here's an example. 1026. The last digit is 6, which is an even number, so that is divisible by 2. I don't even need to try to divide it, I just know. Next, divisible by 3 if the sum of the digits is divisible by 3. So if you're looking at a number like this, 234, the sum of the digits would be 2 plus 3 plus 4, which is 9. And I know that I can divide 9 by 3 and not have a remainder. 9 divided by 3 is 3. So that means 234 would be divisible by 3. That saves me time. I don't have to actually divide by 3. Next one, divisible by 4 if the last 2 digits are divisible by 4. So in 10,812, which would take us a little while to divide if we actually did the division by 4, I look at the last 2 digits, which are 12, and 1 and 2, 12. And 12 can be divided by 4, so that means this number can also be divided by 4. 5 is an easy one. If the last digit is a 0 or a 5, it's automatically divisible by 5. So even in a big number like this in the hundred thousands, the only thing I look at is this. If that's a 5 or a 0, I know I can divide it by 5. We're going to keep going here. A number is divisible by 6 if it meets the rules for 2 and 3. So you'll have to do the rules for 2 and 3, and if it meets both of those, then you know you can divide it by 6. So for example, this number has an even number as its last digit, and if you add them all up, it equals 12. So that satisfies the rule for 3. So this number would be divisible by 6. 8 it gets a little bit harder as we get bigger here. So it's divisible by 8 if the last 3 digits are divisible by 8. So if I take these last 3 numbers and I look at them together and I can divide that by 8, then I know the whole number is divisible by 8. Divisible by 9 if the sum of the digits is divisible by 9, so that one's kind of related to divisible by 3. So in this number, all I do is add up 2 plus 7 plus 6 plus 5 plus 7. If I do that, I get 27. And I know I can divide 9 by 27. Or divide 27 by 9, it's 3, so that is divisible by 9. If I ended up doing the whole 27,657 divided by 9, it would take me a while, but you'd find out there's no remainder. 10 is an easy one. If the number ends in 0, it is divisible by 10. It has to end in 0. Now if you notice, the numbers 1 and 7 don't have rules in this list. The reason is because all whole numbers are divisible by 1, so 1 is going to work with any of these numbers that we did. And 7, there isn't really a rule that works for 7. That one is one you just have to actually do the division to find out if it's divisible. So let's try this. We're going to see which whole numbers from 1 to 10 are factors of 73,500. We're going to use those divisibility rules. So let's start off with 1. I know 1 is because it's a whole number, so that one's easy. 2, we're going to look at the last digit. It's a 0. 0 is even, so it is divisible by 2. For 3, we're going to add these up. 7 plus 5 is 12. 12 plus 3 is 15. So 15 divided by 3, that works. So 3 works. 4, we look at the last two digits. The last two digits are 0, 0, and 0 can be divided by 4. The answer is 0. So 4 works. 5, again, we look at the last digit. It's a 0. The rule was a 0 or a 5, so 5 works. Remember, for 6, it's do 2 and 3 work? Well, yes, 2 and 3 work. So 6 also works. And 7, remember, we're going to have to try. So bear with my sloppy writing here, because we're actually going to do the division to make sure that 7 will work. That would be 1. There. That's a 0. It's a comma, by the way. Bring down my 5. That would be 5. 35. 0. I think you can see that we're going to end up having it work here, because I'm going to bring another 0 down, and then I'll be done. So no remainder. That means 7 works. 8, the last 3 numbers, are they divisible by 8? 5, 0, 0. It looks like we are not going to be divisible by 8 here. So that one's not going to work, and 9 also doesn't work because 15 can't be divided by 9 when I add up my digits. But there it does end in a 0, so 10 would work. So this number is divisible by these numbers. That's all we have for today. I know this lesson can be kind of confusing, so make sure if you need to re-watch any parts, go ahead and do that. Work through your practice problems. Post any questions to the video discussion section, and we'll talk about them next time. We'll see you in the next video.